Hi, I'm Amy Goldman. Today I'll be presenting about making open science more meaningful through ICON principles, and I'll focus on an artificial intelligence machine learning use case for stakeholder engagement throughout the research lifecycle. Before we dive in, I want to pose a question to you. What does meaningful mean to you, to your team, your community, your funding agency? When we think about making open science, or any science, more meaningful, what are we talking about here? This can mean many different things. I don't think there's a singular right answer, but for me, a big piece of making open science more meaningful is about doing something beyond just my research team's goals. Open science has been expanding rapidly, and it's often done in a fairly limited capacity, where discussions are focused on making manuscripts open, or, if we're lucky, data and code open. The paradigm seems to often be, what do I have at the end of my project, and how can I share it? And this is valuable. There are also opportunities to improve upon this approach. From what I've seen, this common paradigm can limit opportunities for sharing and thus engagement with interested parties, and limit accessibility, interoperability, and transferability of resulting work. Shifting this paradigm requires thinking about being open throughout the entire research lifecycle, beginning with ideation, so that decisions are made with intentionality for desired outcomes, like broad, equitable, and mutually beneficial engagement, and maximizing reuse of the resulting work. These lofty goals can seem difficult to reach without guidance. Following a 2018 National Academies of Sciences, Engineering, and Medicine report on open science by design, the Department of Energy released a 2019 report that covered the idea of open watershed science by design, and it introduced the ICON science principles. ICON has grown greatly since then, has been applied to numerous disciplines, and is at the heart of a cooperative developing resources for researchers. ICON is an acronym for Integrated, Coordinated, Open, and Networked, and it's a framework to guide the intentional design of any research motivated by the pursuit of mutual benefit and transferable knowledge. In other words, ICON provides a path to reach our desired outcomes by connecting open science to critical pieces of the research design and implementation. I'll define ICON very briefly before I jump into what this looks like for engagement with folks. ICON talks about intentionally integrating across disciplines and scales, intentionally coordinating with consistent protocols and methods to enable transferability and synthesis, intentionally being both open and fair throughout the research lifecycle from ideation to publication, and intentionally being networked, whereby research is designed and/or implemented with a broad range of interested parties to ensure mutual benefit. This networked piece can happen in a variety of ways, and there are, of course, many kinds of interested parties or stakeholders. A key component is that there is a real engagement so that the research is being informed by stakeholder needs and not an assumption of what the stakeholders want. This is an important part of avoiding parachute science. I'm bringing in this concept of ICON, one, because it's been incredibly valuable for my own work, and two, because this interplay between O and N, open and networked, provides a foundation for a lot of what I'll be sharing in the rest of this talk. Some of the questions ICON asks us to consider are who is present and who is absent when we're designing and implementing our research, who benefits and who's harmed. Can we create opportunities for mutual benefit with the research team and a broader group of interested parties? How are we sharing information with these people to bring them into the work? I'm going to transition now to a specific use case for engagement beyond the research team. Although I'm presenting this in a specific context, the intention is for you to be able to use these ideas in your own work. So very briefly, this use case is part of the PNNL River Corridor Science Focus Area project, and the sampling was implemented through the WHONDRS consortium. We refer to the study as ICON MODEX. The broad goal is to understand and predict sediment respiration as a key but uncertain contributor to river corridor biogeochemical function. The study was designed and implemented to use ICON principles from the very start. It was also built to integrate models with experiments in an iterative loop known to many as MODEX. I'm going to go through the high-level vision of this study first before diving into how this came together in an open, networked way. So we built artificial intelligence machine learning models to predict sediment respiration. We used the model output to identify sampling locations in the contiguous US based on several goals, including reducing model uncertainty. We collected samples and deployed sensors across the US over 18 months. Each month, as we generated new samples and data, we tested the model predictions, rebuilt the models, and generated new predictions. And we repeated this cycle every month to continue improving the models. So what's missing here? I intentionally left some things out of that summary, and I want to go back now and highlight them. Openness and engagement through this principle of being networked for mutual benefit made this study possible. This slide provides a map of how these pieces fit together, and I'm going to get into them in more detail in the next few slides. After the initial study ideation, we went through open collaborative design iteration. The initial models were built using open access data from a prior participatory WHONDRS study that used similar engagement approaches. The sample collection and sensor deployment were done by volunteers across the country, and we worked with them to identify their needs and to meet those through student engagement, early data publishing, and technical scientific engagement. I'll dive a bit deeper now into how these engagement opportunities worked. We widely advertised several virtual open meetings to discuss and get feedback on the draft study design from anyone who wanted to attend. At those discussions, we used Poll Everywhere as one tool to gather real-time feedback from many voices at once. You can see in the first two images on this slide some real poll responses from two of the meetings. We asked about data types of interest, and then at a subsequent meeting had a specific data type list for comment. As a result of these discussions, we made changes to the study design, including adding time series sampling and adding new analyses. We wanted to make sure the study design was useful to people beyond our immediate research team, and this also improved the science that we're doing, opening the door to asking new scientific questions. To collect samples and sensor data, we sent kits out to people who volunteered to sample in the contiguous US. You can see the map on the right of where we were able to collect samples through this collaboration. The geographic focus is related to some logistical elements, and it's important to note that it does limit the people who could be involved in this part of the study. The folks who sampled could be researchers or non-researchers. We widely advertised the opportunity to sample, and we worked with these collaborators to identify sampling locations that were not just useful to our project, but also of interest to their research or community. Many times, this involved us incorporating new sites into the machine learning models to find locations that were at this nexus of mutual benefit for us and our collaborators. We ultimately worked with 142 collaborators to collect 113 sampling kits, which resulted in about 1,700 samples collected in the field. A major motivating question to us is always, what do our collaborators want? How can we find, as I mentioned, the nexus for mutual benefit that allows us to reach our required science goals while also meeting or exceeding their needs? This is a major piece for me in making open science more meaningful. When we engaged with collaborators during multiple different points, we heard about their needs and interests. One thing that came up was an interest in classroom engagements and field activities for students. As a result, we started holding virtual presentations for classrooms and other outreach groups. We sent mock sampling kits so that there was a physical component, and we also provided the opportunity for the students to collect very simple data types like temperature and pH that could then be used to add field sites of interest to them into the machine learning model. If they didn't have instruments to get the data, we provided sensors to make sure that everyone interested could participate. We also heard from collaborators about the data types that were of most interest to them. To facilitate rapid data use, we published data in batches as soon as they were quality checked, rather than waiting until the end of the study. The data follow specific community reporting formats associated with the data repository in alignment with FAIR principles to facilitate reuse. And it's important to us that these collaborators have the same access to the data that we have, so we don't use the data for our own analyses before publishing it. The collaborators who collected samples also have the option to be listed as co-authors on the data package. And we heard from collaborators that they were interested in building their own networks of collaborators, building new skills, and having opportunities to work with others to publish manuscripts. As a result, we held a workshop for an open collaborative analysis and writing opportunity. We've used this approach before with great success. Anyone interested comes together to meet each other, analyze data together, learn from each other, and write a manuscript together. We're currently in the analysis and figure-making phase of this particular manuscript. I want to go back now to this idea of what is meaningful. Through the use of ICON, and especially from using the open and networked principles together, we were able to achieve our research goals. We have a great distribution of samples, we built a predictive model with excellent success, and we're still generating more data that will be used for scientific questions. But once again, what's missing here? Through the use of ICON, and especially from using the open and networked principles together throughout the research lifecycle, we were able to work with hundreds of collaborators, listen to their needs, and meet those. We were able to do better science for ourselves and create something much larger, something that enables transferable understanding and operates at the nexus of mutual benefit between this single small research team and a much broader community. To me, this is what making open science more meaningful is about. Thank you.